Welcome everybody to Trigonometry, aka SOH CAH TOA. So, what is SOH CAH TOA? You would have seen this before. SOH CAH TOA is the sine of the angle is opposite over hypotenuse. The cos of an angle is adjacent over hypotenuse. And the tan of an angle is opposite over adjacent. So what we now need to do is label the triangle. So, opposite is opposite the angle we're trying to find. So where's our angle? Here. Opposite the angle is this side here. So this is O for opposite. The opposite is always opposite the angle we're trying to find. That is a rule. The hypotenuse is the longest angle on a right angle triangle. This is the one that's opposite the 90 degrees. Here it is. Some of you know when we do Pythagoras, this is our C, opposite the right angle. Yeah, it is the hypotenuse, and then A is the one that's left over. Now, just a few rules. SOH CAH TOA can only be used on right angle triangles. Do we have a right angle triangle? Yes, we can use SOH CAH TOA. Step 1, label the triangle. So now you've labelled the triangle. What we're going to do now is, what information do we have? So I'm going to use a highlighter because I love a highlighter. Do we have H? Do we have any information for H? No. Do we have any information for A? Yes. A is in fact 8. Do we have any information for O? Yes. O is in fact 3. Now, so that means I have A and O. I have a look at all my formulas. Which one has A and O in them? Tan. It has O over A. So that means this is the formula I'm going to use. Alternatively, if you write SOH CAH TOA, just look for the one with O and A. And that is tan, isn't it? So I'm going to fill in everything I know. So now all we're doing is substitution. So tan of my angle X equals my opposite, which is 3, over my adjacent, which is 8. So I filled in the formula. Now, how do I find X? So we're going to have a quick side note. So here's the side note. You know, if we have X squared equals 16, how do we find X? We square root both sides, because the inverse of squaring is square root. So we square root 16, and this would give us 4, well, plus or minus 4 technically, but we'll come to that in a different session. So what is the inverse of tan? Now, in our calculator, if you have a look, you can press Shift tan. So we're going to get tan to the minus 1 bracket 3 over 8. Okay, so I'm going to put this in my calculator. This is how it should look. Okay. Also, make sure that your calculator is in degrees, because we're working in degrees. So shift tan 3 over 8 is 20.55. So X equals 20.556. I'm going to go back and read the question, and the question says, give your value correct to 1 decimal place. So X equals 20.6 degrees. Nice and simple. Okay, so for the second question, I want you to have a look at the second question. What is different from the first to the second question? So after some discussion, well done. For this one, it is a right angle, check. We're going to label it opposite, because it's opposite the 72 angle. This one is my hypotenuse, because it's opposite the right angle, and the one that's left is the adjacent. Now, what I notice is if I highlight everything I have, oh, sorry, that was not the highlighter. I have A, and I have an angle. So this time, I don't have two sides. But if I read the question actually says, calculate the length of MN. It wants us to calculate a length, MN. MN is this length here, which is in fact our opposite. So again, what do we have? A in the angle. What do we want? O. So if I look at SOH CAH TOA, SOH CAH TOA, what do I have and what do I want? I'm going to highlight. I have A, right? So I definitely know I'm not using sine. Yeah, that one's out of the question now. And what do I want? O. Okay, so it's tan again. Okay. So tan of x equals opposite over adjacent. I'm going to fill in everything I have. Tan of x. Now we know x is the angle. We actually have the angle in the question, don't we? 72 equals my opposite, which I'm not sure of yet, over my adjacent, which is 34. Now, another side note, we have to think about this as a rearrangement. Imagine, we all know that speed equals distance over time. That's a formula that we know, isn't it? So imagine our tan is our S, our O is our D, and our 34 is our T. What do we actually want? We want D. We want the numerator of the fraction, which is our opposite. So how am I going to rearrange this equation? What does distance equal? Absolutely. Distance equals speed multiplied by time. Now, whenever I'm rearranging, if I'm a little bit unsure, I always go back to this. Okay. So that means tan 72 multiplied by 34 equals the length. So this time in my calculator, I'm just going to write tan 72. I haven't done the inverse because I am not trying to find the angle. So here we go. Type that into my calculator and I'm going to get 104.641. Okay, so I read the question again. It says, give your answer correct to three significant figures. 104.6412 to three significant figures. First significant figure is hundreds, second significant figure is tens, third significant figure is units. So three significant figures actually means round to the nearest unit for this question. Yeah? So that would be 104.64 to the nearest unit is actually 105 centimetres. Okay, so here we have question 3, where we're going to practice the two skills. We're going to find the angle on part A, and for part B, we're going to find a length. Off you go. Give it a go. So remember, SOH CAH TOA. Okay. Remember rearranging formulas. Think about how you'd rearrange speed equals distance over time, because that's essentially what we're doing. Try and relate it to previous rearranging. Off you go. Okay, so now that you've had time to go through this, step 1, is it right angle? Yes, I'm going to label it. Opposite, the right angle is my hypotenuse. Opposite, I nearly said a hippopotamus then. Opposite the angle is my opposite, and then what's left is my adjacent. Okay, so this one's nice and easy. What do I have? 4 and 8. What do I want? The angle. Brilliant. So O and H is sine. So that means sine of my angle equals opposite over hypotenuse. Sine of my angle equals 4 over 8. So that means my angle is inverse sine of 4 over 8. I'm going to put that into my calculator and I'm going to get 30 degrees. Now this is actually a nice whole number. I didn't have to round any of that. Now if you were in the UK, you'd actually have to learn that sine of a half is 30 degrees. Okay? You have to know that off by heart because one of their papers is non-calculator. Right, Okay, so the second part again, is it right angle? Yes. Okay, step one, label my sides. Hypotenuse, opposite, adjacent. Okay, I've actually missed a really important step. Whenever we do questions, technically we should read the question, shouldn't we? Okay, so the diagram shows the triangle, check. MN equals 12, did they put that on? MN equals 12, yes. Angle LMN is 32, yes, because sometimes they write this down, but they don't actually write it on the diagram. So we always need to double check. And angle MLN is 90 degrees. Brilliant. Calculate the length of ML. Okay, ML is here. Okay, so what do I have? I have the angle and I have the hypotenuse. What do I want? A. So I have a look. Which one has A and H in it? Cos. So cos of the angle equals adjacent over hypotenuse. So let's fill in everything we have. Cos of 32 equals A, which we don't know, over 12. Okay, I need A, don't I? I rearrange. So I think to myself again, speed equals distance over time. I have a look up here. So if I want the distance, right, I know that speed times time equals distance. Now, some of you may use these triangles, okay? You know, where we have speed, distance, time. I know some of you have been using them. I really don't like the triangles because it doesn't really help with understanding. However, you can, if you want to, use these triangles, so SOH, okay? So for CAH, C, A, H, what do we want? A, so it's C multiplied by H. Personally, I think as mathematicians, we should all be confident rearranging. But for today, if rearranging is a skill we need to practice on a separate day, that's okay. If the triangle works for you, for today's lesson only, whilst we practice labeling, I will allow it. But ideally, we are going to come to rearranging and practice that skill. So that means that cos of 32 times 12 equals my adjacent. So I'm going to put that into my calculator. Cos 32 times 12, and I get 10.1765, blah, 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 blah. I then read the last part of the instructions. Give your answers correct, 3 significant figures. The first significant figure is tens. Second significant figure is unit. Third significant figure is 1 decimal place. So for this question, I have to round to 1 decimal place, which is 10.2 centimeters. Well done. Okay, before we move on to problem solving type questions, we have two more for you to practice, and then we're going to move on to some problem solving type where there isn't just a triangle. So 2 more practicing the skill, off you go. Okay, so very quickly going to run through this. Step 1, right angle, yes, it wants an angle. I'm going to read the question, label the sides. So opposite, hypotenuse, adjacent. Okay, what do I have? A, I, what do I want? X. Okay, so SOH CAH TOA. This is O and A, it's tan. So tan of X equals opposite over adjacent. Tan of X equals 5.1 divided by 4.2. So X is the inverse of tan. So in my calculator, remember, I need to click Shift tan. Shift tan 5.1 over 4.2, 50, so X equals 50.527, dot, dot, dot. 3 significant figures is, first significant figure is tens, units, 1 decimal place. So this means for this question, I'm rounding to 1 decimal place, 50.5 degrees. Okay, second part of the question. Sorry, I should have zoomed in on the first one. Okay, so read the question, calculate the length of AB. So I want this. Give your answer to 3 significant figures. So that's what I'm rounding. Okay, I see it's a right angle. I see I have a degree and a length. So, first of all, label opposite hypotenuse A. Then, what do I have? I have H. I have the angle. What do I want? I want O. So it's O and H. Which one's O and H? Sine. So I write the formula. Sine of the angle equals opposite over hypotenuse. Now, I always write this formula before filling it in, just to make sure I put everything in the right place. Sine of 29 equals O over H, which is 5. How do I rearrange this? I need to multiply both sides by 5. So my opposite equals sine of 29 times 5. Sine 29 times 5 equals 2.424 ... 3 significant figures. The first significant figure is a unit. Second significant figure is a first decimal place. Third significant figure is a second decimal place. So this, for this question, means round to 2 decimal places. I don't know why I put PD. Sorry, DP. So 4.242 is 4.42 to 2 decimal places. Now, something we haven't come across yet, and we're just going to have a little side note. I want you to try this question again, okay? So I'm just going to rub all this out. We're going to try this question again, but this time, you're told that this is 4 centimeters and you have to find the length AC, sorry. So you have to find this length AC. Okay? Give that one a go for me. Off we go. So for this one, what do? We highlight what we have. Oh, sorry. Before we highlight, let's label. So we have opposite, hypotenuse, adjacent. Okay, so we're now going to highlight what we have. We have O, we have the angle. What do we want? We want H. So it is O and H, which we know SOH CAH TOA is sine of the angle equals opposite over hypotenuse. Okay? So sine of 29 equals 4 over H. So we haven't seen one like this before. Okay, because I have to fill in everything I know. How do we rearrange this to find H? Have a think about this for a second. If you need to use those triangles, you can. How would I now find H? What does H equal? What am I going to put into my calculator to find H? Okay, so I'm going to explain this 2 different ways because 2 different people answered. Sine of 29 equals 4 over H. How are we going to get H on its own? Well, they said let's multiply both sides by H. Then that's going to cancel. And we're going to get H times sine of 29 equals 4. And then how do we get H on its own? We're going to divide both sides by sine of 29. Okay, so that means these are going to cancel to make 1. So I'm going to get H equals 4 over sine of 29. This is fantastic, and this is the level of mathematics we need in understanding. Okay. However, for some of us today, we just want to learn this skill, and we're going to practice rearranging another day. Let's go back to this triangle. So we have SOH. Okay, what are we trying to find? H. So you know how to use this triangle. Cover up the H. What does it tell us to do? Opposite divided by sine. Now, we've proved that here using an algebraic method, which is fantastic. This is why the triangle works. Opposite over sine. So we're going to have 4 over sine of 29. 4 divided by sine of 29 is going to give me 8.2506 ... Three significant figures. The first one is units, second one is 1 decimal place, third one is 2 decimal places. So that means for this question I round to 2 decimal places, which is 8.25. Well done. So if you want to do some more practice, you can here. We're going to move straight on to something a little bit different right now. Okay, this is more like it. Now, even though sometimes we do get a question in the exam which is just a triangle, like the one you've just seen. It happens. We just did a mock, didn't we? And one of the questions was very simple. It was just a triangle. Sometimes we're lucky like this. Sometimes we're also lucky if we get a problem-solving one. Because this time, before we get to the stage of labelling, we actually need to read the question and find out what's going on. So let's do this together. ABCD is a trapezium. AB is 25. So remember, as we read through, AB is 25. Have I got 25? Yes, I'm mentally checking this off. BC is 24. 24, BC, check. CD is 10. Check. Angle ABC, so that's ABC is 90, which is BCD. BCD, 90, check. Calculate the size of angle CDA. Okay, so what I like to do is CDA. So I need to calculate the size of this angle. This is what it's asking me to do, isn't it? So what I notice is this trapezium is actually, and a lot of trapeziums are normally made out of rectangles and triangles. So what I'm going to do is I'm going to split this shape. We have here, we can see we have our rectangle. Now, as you know, is this the method you would use? Okay, remember, compare your method to my method. This is the time that we're going to compare. Okay, so we know that this is a rectangle, so this is 90. And then we need to find this angle here. So to find the angle CDA, I need to do 90 plus this angle, which I'm going to label X. And this is going to give me that whole green angle. So if I just think about this triangle for a second, I have this triangle. I need to find X. I know this length is 25. Remember, this is our A and D. All I'm doing is taking this triangle out and I'm redrawing it so I can visualize this in my head and on paper. I don't know what this point is, but I know this is a straight line. The facts we know about rectangles: if BC is 24, then this length is also 24. So this becomes 24. And we know that this must be a right angle if I've created a right angle triangle. If this is a right angle, this is a right angle, it's a complete straight line. What do I now notice? Because at first I didn't know that this was actually going to be a trigonometric question. I mean, I did because that's the topic today, but when I first looked at the question, I didn't until I looked a little bit further. I noticed I have two sides and an angle, and it's a right angle. So what do I immediately write down? SOH CAH TOA. Okay, label my triangle. Opposite the right angle, hypotenuse. Opposite the angle, O. The last one is adjacent. What do I have? I have O. I have A. What do I want? I want X. Which one has O and A in? Tan. So that means tan of X equals opposite over adjacent. I always write the formula down first and then I substitute. So tan of X equals 25 divided by 24. So if I want to find the angle, I know I'm going to have to do the inverse of tan 25 over 24. So shift tan, brackets, 25 over 24, close brackets, 46.169, ... Okay, I'm not going to round that yet because I haven't finished the question. So now going back, now I found this angle X. I know this is 90. To then find the whole angle, I need to add them together. So what I'm now going to do in my calculator is I'm just going to press plus 90. So 46.169 ... plus 90. And then I'm not losing any accuracy. Okay, and in my calculator, that will show up as ANS answer plus 90, which is 136.169, blah, blah, blah. I then have a look, 3 significant figures. My first significant figure is hundreds, second significant figures is tens, first significant figures is units. That means I round to the nearest unit, which is in fact 136 degrees. Okay, now I have finished. I want us, because when we're doing a problem solving question as well, like I'm just going to add something in. Think about this realistically. So we finished the question, which is great. You know what we're going to start doing now? Okay. Think about this angle. If I had a protractor and measured that, does that look like roughly 136 degrees? Yeah. Because we know, we think about angles, this is a straight line. From here to here would be 90. So we know 136 must be here roughly. So we expect 136 to be an angle like this. We have to check, does it make sense? Because for example, if you look at this angle A here, what would you expect that angle to be? We'd expect this to be less than 90, wouldn't we? If you were to guess, we know that 90, this would have to be a straight line for this to be 90. So if you were to guess, how big would this angle be if you were to guess? Yeah, it could be about 30, couldn't it? Could be about 40. Could that angle be 150? No. So that's why we have to say, does this make sense? Yes, it does. This is just something added on. We should always be checking, does this make sense? Okay. So some of you may be sat here now thinking, wow, this is great. And some of you may be sat here now thinking, oh, there's been a huge mistake that's been made. And there is. There's a classic mistake. When I've redrawn this triangle, okay, is this length 25? No. What is the length? 15. Because remember, this is 10. This is 24. So this length here should in fact be 15. So we're going to go back and we are going to change what we've done. So even though our angle, it did make sense, let's go back and change this. So this is why it's really important, whenever you finish your exam early, to go back and check. Those of you who spotted that classic mistake, very impressed. This is something that we should be questioning all the time. Okay, so now shift tan 15 over 24, x equals 005 degrees. I'm going to add 90 to my answer, and I'm going to have 122.005. Round that to 3 significant figures is 122 degrees. Now, you can actually see 122 degrees, and that angle still makes sense. And 136 still makes sense. But you can also see how easy it is to make mistakes. And we really need to focus on every single detail. Well done. So, just to finish off this one with a few points. It is easy to make mistakes. Today we are focusing on being able to substitute into a formula. Now that you've made this mistake, some of you may have, some of you may not have, this is something that you need to celebrate and just say, okay, do you know what? I've now made this mistake. Next time I'm always going to double check that the lengths make sense. So well done. Okay, here's a different type of question. Okay, question 10. 6 marks, ideally 6 minutes, off you go. It says ABC is a triangle. The point D lies on AC. The angle BDC is 90. So BDC is 90. Guys, if this is a straight line, this is also then 90. BD is 10, check. AB is 15, check. DC is 12.5. Calculate the length of AD. Now, I know what you're thinking. We have angles, we have right angle triangles. So you're thinking SOH CAH TOA. However, you remember Pythagoras that we did yesterday? So if we have two lengths and we want another length, we have to use Pythagoras. We only use SOH CAH TOA trigonometry if we have a right angle triangle and we have angles involved. So you need to remember that when we get into these questions, we do a little bit harder. Actually, what you find is that other skills are going to come involved. So we know this is our A, B, C. We know A squared plus B squared equals C squared. So we're going to have 10 squared plus B squared equals 15 squared. So B squared equals 15 squared minus 10 squared. So B equals the square root of 15 squared minus 10 squared, which is a root 125. It wants the answer to three significant figures. So 11.180, three significant figures. First one, 10. Second, units. Third, 1 decimal place. So I'm going to round to 1 decimal place, which is 11.2. Normally what we'd find is the questions would actually give us B, and then we had to find A, because then that would give us the next step to enable to find the angle, okay? So then calculate the size of the angle. So question 11, we've been given a triangle, and we've checked all of this, and they've told us the area of the triangle is 60. So the first thing I'm thinking, area of a triangle that's a right angle, base times height divided by 2 is the area. That equals 60. It says work out the size of the angle SQR. SQR means I want this angle here. So, if I label my triangle, I've got an opposite, I've got an adjacent, I've got a hypotenuse. Remember, I want the angle. So if I think about what I want X, I have A, I'm like, hold on a minute, I don't have anything else. And then I have to think, okay, go back to the question. What did the question say? Area of triangle is QRS. Okay? So if I think about this triangle, I know that the base times the height divided by 2 is 360. So I don't know what my base is. I know my height is 15. Divide that by 2 equals 60. So base times height must equal 60 times 2, which is 120. So my base is 120 divided by 15, which is in fact 8. So that actually leads me to believe that my opposite is in fact 8. Brilliant, I can carry on with the question now. Right, so what do I have? O and A, what do I want? The angle. So O and A, SOH CAH TOA. Tan of the angle equals opposite over adjacent. Tan of the angle equals 8 over 15. X equals inverse tan of 8 over 15. Shift tan 8 over 15 equals 28.0724. 28.0724. Now, it says round to 1 decimal place. That's easy. 1 decimal place. It's going to be 28.1 degrees. There we go. Nice and simple. So this time we've had to use different information. Question 13 is similar to what I was saying earlier with regards to, I've looked at this question, I've read the whole thing, and to find this angle, I need to do Pythagoras to find this length. Then I'm going to be able to use this length and this length to find the angle. Here we have another multi-step problem. So again, you'd read the whole question, okay, give it a read. It says, work out the length of QR. QR is here, okay? So just pause this video now. Have a think about how you're going to do it. Okay, well done. So what we do know is that to find that length, I need another length. So I'm actually going to find this length first. So step 1 is finding this green length using SOH CAH TOA. Then step 2, to find the length we actually want, I'll be able to use my answer from step 1, and then I'll use SOH CAH TOA again to find that length. Question 16. Now I wonder if you can give this a go quickly. It's probably one of my favourite types of questions, this one. So press pause, and then I am actually going to go through this whole question. Okay, so here we go. Triangle ABC is right angled at B. Angle BAC is 32, check. AC is 47, check. D is the point on AB such that BDC is 51, check. Calculate the length of BD. Okay, so it wants this length. Brilliant. So if it wants that length, what I'm going to do is draw this triangle. I'm going to draw this triangle again here. This is B, C, D. I have 51 degrees, okay? I want this length. What do I know? If I have an angle and length and it's a right angle, I know this is going to be SOH CAH TOA, okay? I have an angle, I have my x. If I label my triangle quickly, I have a hypotenuse, I have an opposite, I have an adjacent. So either way, I need to find either my hypotenuse or opposite to enable me to discover which formula I'm going to use to help me. Okay, so that's step 1. I've broke it down. I know what I have. I now know what I need to do to get there. So then I look at the triangle again. Now, one of the most common mistakes we have is that people see this triangle here, this ACD. Okay, it's 47. This is 32. This angle we can work out because we know angles on a straight line add up to 180. So if I do 180 minus 51, I'm going to get 129. Okay. Now, what I notice about this, I can't actually do anything with this yet. I don't have a right angle. So this is not the way forward. That's okay. I've tried something. I've realised I can't do anything with it. But I've also practiced my skills on angles on a straight line add up to 180, so that's fine. So then I look at this again. What other triangle can I see? I see a really big triangle. Here we go. This is BCA. This actually contains a right angle. This is 32 degrees, and I've told my length is 47. Well, this is perfect. Because I said earlier that I either need DC or CB. If I've got a side, a length, and an angle, I can either find AB or CB. Well, I want CB. So brilliant. So I'm going to work out CB. This is then going to go here to allow me to find the other length. Fantastic. I have a right angle, triangle, I have an angle, I have a length. So let's start labeling. H, O, A. So for this triangle, what do I have? I have my angle, I have my hypotenuse, and I want the opposite. So O and H is sine. Sine of x equals opposite over hypotenuse. My sine of 32 equals my opposite over 47. So opposite equals sine of 32 times 47. So I'm going to write that into my calculator. Sine of 32 times 47, which is 24.906. So opposite equals 24.906, dot, 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 dot. I'm going to keep that as that is, okay? And in my calculator, that's currently what it shows. So brilliant, I've now worked that out. So now I think here, what do I have? I have A and O, okay, which is in fact tan. So tan of x equals opposite over adjacent. Tan of 51 equals the opposite, which we now know is 24.906, blah, 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 over my adjacent, okay? How do I rearrange this? I multiply both sides by A and then divide both sides by tan 51. So A equals 24.906, blah, 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 divided by tan 51. Now, a nice little shortcut is that I'm now going to write on my calculator, because I technically, wait there, I'm going to take a photo. So I still have my sine 32 times 47, and this is where I've got the 24.906, blah, blah, blah. And then what I'm literally going to type is divide tan 51, and then it changes that value into answer, so I can keep it exact, okay? So I just literally write divide tan 51, and I get 20.1686, blah, blah, blah. And then it says round correct three significant figures. So this is, in this case, one decimal place, which is 20.2 meters, because the question was in meters. I always look for units. Okay? So you can see here how this was a multi-step problem. And whenever we have multi-steps problem, it's really good to keep this as exact as possible. So well done. Okay, question 14, slightly different. Pause it here before you start it, and then I'm going to give you a few bits of advice. Okay, after reading this question, I can see we know that angles in a semicircle form a right angle. Okay, so they haven't told us that, but we know that is the reason from circle theorems. Okay, so it's bringing in different skills. We know that this is the hypotenuse. However, our hypotenuse is in fact two lots of the radius. It's in fact the diameter. So we can see here, this is the center. So we might need that fact, because when we figure out this triangle, I'll show you now. So step one, use SOH CAH TOA on the triangle AOB. So we have 30, we have 8, and find the length OB. If you now double that length, you're going to get the diameter. For the second triangle, which is in fact BDC, this is in fact two lots of, okay, this is two lots of the green, because technically what we found here is the radius, and we know that this is the diameter. And then from there, you have the green length, the diameter, you have your angle, and the question wants you to find the length of BC, which is here. So then you'll have a length, an angle, and you want to find BC. And there we go. It's about breaking down the question and spotting what you have to do. Okay, well done. This is trigonometry plus some extra bits and also watching out for mistakes. Have a great day.